So we have a differential equation. dy dt is ky, y of 0 is 50, y of 1 is 75. So this example is exponential growth and decay. It is a separable differential equation. So we've got to get all the y's on one side, all the t's on the other. So how am I going to do that? If I divide by y, I get dy over y here, multiplied by dt. In essence, I have k dt there. So we've got the integral of dy over y is the integral of k dt, which of course is the integral of 1 over y dy, which is k times the integral of 1 dt. Integral of 1 over y is natural log absolute value of y plus c. We'll work on the c on the right-hand side. K times the integral of 1 dt, a function whose derivative is 1, it's just t. So we get kt plus c. So now I have natural log absolute value of y equals kt plus c. Where do we go from there? The base of the natural log is e. So we have e to the kt plus c will equal the absolute value of y. E to the kt plus c is the absolute value of y. Now e to the kt plus c is the same as e to the kt times e to the c is absolute value of y. But e is 2.718 approximately. C is an arbitrary constant. So 2.718 to an arbitrary constant is just a much bigger arbitrary constant. But it's still arbitrary, c e to the kt. But if we allow it to be positive or negative, we have to relax the absolute value signs. So we get y equals c e to the kt equals y. Okay, now what am I given? 2 bits of information here on this differential equation. Y of 0 equals 50, which means when t equals 0, y equals 50. So if I plug in a t of 0, I get what? I get c e to the k times 0, plugging in a 0 for t, equals y. What is y? Y is 50. So that c e to the 0 equals 50. E to the 0 is 1, so we get c equals 50. Okay. I've got to use my other bit of information, namely that y of 1 is 75. So what we have now is we have y equals c e to the kt. But c is 50. So y equals 50 e to the kt. Using my information, when y is 1, excuse me, when t is 1, y is 75. When t is 1, y is 75. So making that substitution, what do we get? We get 75 equals 50 e to the kt. But t is what? T is 1. 50 e to the k times 1. Dividing both sides by 50, what do we get? 75 divided by 50 is 1.5 or 3/2. So 3/2 equals e to the k. Then we will hit both sides of the natural log. So natural log 3/2 is natural log e to the k, which is just k. So natural log 3/2 is a decimal approximation. Natural log 3/2 is about 0.4055, we'll call it. 0.4055 equals k. And I think we are ready to go ahead and write the solution to this differential equation. What was our form? Our form was y equals c e to the kt. Our first bit of information, the fact that y of 0 was 10, gave us c was 50. So we had y equals 50 e to the kt. And k is our growth factor. K is positive, so it's growing. Our k here was 0.4055. We got that from the fact that y of 1 was 75. So you can go ahead and make that substitution and say y is 50 e to the 0.4055, approximately, t. Again, if K is positive, it's growing. If K is negative, it is shrinking. And some of our favorite applications follow this model. Continuous compound interest does. Certain growth elements like inflation follow it, and decay elements like radioactive decay would work off this model where the growth rate, dy dt, the rate at which something is growing is proportional to how much we have.